So we're coming back to this booklet that you see in your notes on page 23. You have this already, so you can kind of fill this in as we go. We've already discussed standard form, which is ax plus by equals c. So we're moving on to point slope form. And I want you to go ahead and write this on your foldable down here in this little tab. Point slope form is y minus y1 equals m times x minus x1. And we're going to talk about what of those variables, which of those variables, what do they mean, and which ones do we fill in. You should know by now from looking at enough linear equations that in every form that we use, the only variables that are left when we actually write all the numbers in place of the other variables, all that's left are x and y. Everything else turns to numbers. So in this equation here, that means that x and y are going to remain, but y1 and x1 and m are going to be filled in with numbers. So we're going to talk about what point slope form looks like and what we use it for. So we very rarely use point slope form for anything other than getting to an equation. We very rarely, I can't think of very many examples where we actually use point slope form to graph, because you just can't graph in point slope form. You'd have to convert it to either standard form and then graph the x and y intercepts, or you'd have to convert it to point slope intercept form and then plot the y-intercept and the slope. So the only thing that we use point slope form for is simply to help us write some equations. So if you'll look in your textbook on pages 64 and 65, you'll see the two instances that we have to use point slope form, okay? But let's make sure we understand what point slope form is, okay? So the first thing that you should recognize about point slope form is that the x and the y are on opposite sides. Now, in standard form, they're on the same side. But point slope form and slope intercept form both have the x and y on opposite sides. You can see that. In point slope form, the y's are over here, the x's are over here. In slope intercept form, y is on the left and x is on the right. So the question is, what separates point slope? Okay? So the one thing that you will recognize about point slope form is that makes it unique from slope intercept is that point slope form is the only form of linear equations that have parentheses. And they're on the side that's with the x. Okay, so if you look at it again, you're going to see parentheses on this side with the x. None of the other forms have parentheses. That's how you'll know that something is in point slope form. So what do the other variables stand for? Well, the m means the same thing that it does in slope intercept form. The m is the slope, okay? And then the only other thing that gets filled in is the x1 and the y1. And the x1, comma, y1 is simply a point that is given in the problem that is located on the line, okay? That's all that x1, y1 means. It just means the coordinates of a point given in the problem, okay? So that's what makes point slope form unique. The parentheses make it unique, and the fact that it has this x1, y1 makes it unique. None of the other ones have x1, y1. Okay? All right, so let's move on to why we use point slope form. Notice I don't have any graphs on this page because we don't use point slope form to graph. We use point slope form to write equations, and we can do it in two instances. Here's number one, and here's number two. The first instance that we do it is when we are given the slope and a point. A slope and a point are not enough information to write it in standard form. It's also not enough information to write it in slope intercept form. So the only thing we can do is start out by using point slope form and then convert to another form of an equation that they're asking for us, okay? So here's how we do this if we're given a slope and a point. If we're given the slope gets plugged in for m. So you fill the slope in for m in the equation. So I'm going to write the equation off to the side here again. So I don't have to keep switching back. Okay? Oh, well, you know what? I can write it down here. So I'm going to be filling that equation in, and I'm going to be filling in the m and the x1 and the y1. So the m is given to you if they give you the slope. Then we're going to, after that, plug in the x1, y1 values of the point that's given in the problem, because they're going to give us a point and a slope. And then we can convert to any equation it's asking us to. Okay, we can convert from point slope to standard form. We can convert from standard form to slope intercept form. We'll talk about how to do that when we get to the slope intercept form. Okay, so look at the example here. It says write in standard form the equation of a line that has a slope 2 and it goes through the point 4, -2. So there's the slope right there. That's the m. And then this is x1, y1. So I'm going to go to my equation and I'm going to fill in the values that I have been given for the different things in the problem. So the y1's going to get replaced with a -2, but be careful, there's already a minus. So if the y value is also -2, that's going to change to a plus. We'll fix that in a minute. M is the slope, and that's 2. And then x1 is 4. So I'm just going to do x minus 4. And now I'm going to simplify, and I'm going to eventually get it in standard form. So let me finish putting it in. Oh, that's bright. Let me go back and do a darker color. This is going to change to plus, right? So it's going to be plus 2 equals 2 times x minus 4. There's point slope form, okay? So now I'm going to change it into standard form. In order to get it into standard form, I'm going to need to get the x and y on the same side. So what I'm going to do first is I'm going to go ahead and I'm going to do this down here. I'm going to distribute the right side. That's 2 times x, which is 2x, and 2 times -4, which is 8. So I got y plus 2 equals 2x plus 8. To get it in standard form, I need the x and y on the same side. So I'm going to move this 2 because I don't want the number on the left side. I just want the x and y terms on the left side. Remember, standard form is this. The c is a single number. I want the number on the right and the x term and y term on the left. So if I move this 2, I'm going to get 2x plus, oh, I'm sorry, it's a minus 8. Sorry, it was a minus. I did not see that. -8 minus 2 is going to make this turn to a plus as well, or to a minus, and that's going to be -10. Now, if I want to get this in standard form, this x term needs to move over here. So I'm going to do that by subtracting 2x, and that presents a problem because when it's in standard form, I'm not supposed to have an x term that's negative, and I do. So in order for me to get rid of that, I'm going to have to multiply everything by -1. So the -1 times -2 is going to become a positive 2. The -1 times y is going to become -y. And the -1 times -10 is going to become positive 10. So there is my standard form of this equation, okay? And I couldn't get to that point, though, because all they gave me was a slope and a point, so I have to use point slope form. So the other time that I use point slope form is when I am asked to find the equation and all I'm given is 2 points. So if I'm given 2 points, I have a little extra work to do because I don't know the slope. The slope is the m, but they didn't tell me the slope if they only gave me 2 points. So I'm going to have to use slope formula first to actually find the m. So I got to do slope formula. That's an extra step. And then I'm going to plug in the value of either point for x1, y1. They gave you 2 points on the line. It doesn't matter which one is x1 and y1. Any point on the line can fit in for x1, y1. Now this one is going to ask me to just go ahead and keep it in point slope form, which is kind of nice. I don't have to do any converting, okay? But they've given me 2 points. Now remember what we talked about. When we do slope formula, because I got to find the slope, I would like to be able to not have to mess with negatives. I do notice, however, though, that both y values are negative. So no matter what I do, I'm going to have to change the sign on a y value. So it really doesn't matter which one I use as x1, y1. So I'll just keep them as in the order they're in. All right, so I'm going to do the slope formula now using those values. All right, so y2 is -1 minus y1 is -3. So be careful, that sign's going to get changed here in a minute. x2 is 5 minus x1 is 4. So when I simplify this, when I change those signs to both plus signs, I'm going to get this. That's the same thing as 2 over 1. So the slope is just plain old 2. Now I can use the point slope form because I've got the slope right here. And I've got 2 points and I can use either one. So for y1, I'll just go ahead and put in the -3. Remember, that's going to change to a +3. The m is the slope, and that's a 2. And then the y1 is a 4. You do have to, once you pick which one is going to be your x1, y1, you got to keep it consistent. You can't pick like the y1 from here and the x2 from here. You've got to keep them from the same point. And then from here, I'm just going to rewrite it so that way this is still only one sign right there. But the equation told me to leave it in point slope form. So I'm going to leave it exactly like that. That's point slope form. Now, if you were asked to convert to standard form, you would have to get the x and y on the same side. And if you were asked to convert to slope intercept, you'd have to get the y by itself. But we'll talk about slope intercept form next. So point slope is never used for graphing. It's only used for setting up and writing the linear equations.